Hey guys, we're going to do 3.7 today, and this is L'Hopital's rule, so go ahead and do the warm-up. You're going to find your first derivative on 1 and 2, and then you find your limit on 3 and 4. Okay, so on number 1, we're just doing our derivative, so let's think about the first one. We have y prime, derivative of natural log, so that would be 1 over x plus 1. The derivative of x plus 1 is just 1, so I'm done there. And then minus derivative of e to the x is e to the x. Okay, number 2, we have quotient rule. So dy dt equals derivative of the top, 1 over t, times the bottom, which is just t, minus derivative of the bottom, which is 1, times the top, natural log of t, all over the bottom squared. I will reduce that one more because these t's cancel. So 1 minus natural log t over t squared. Okay, on number 3, finding the limit. If you plug in a 0, if you try to plug in a 0, you end up with 0 over 0. So that's no good. But hopefully you noticed that you can split this as 3x over x minus sine x over x. And remember that the limit as x goes to 0 of sine x over x is 1. So this becomes, with the x's canceling, 3 minus 1, which is 2. Okay, number 4, if we plug in a 0, we get 0 over 0. Again, that's no good. So we should try to multiply by the conjugates. 1 plus x plus 1 on the top and bottom. Okay, so on the top, limit x approaching 0. So on the top, I get 1 plus x minus 1. On the bottom, I get x times radical 1 plus x plus 1. On the top, my 1's are going to cancel. Then I can have just an x. That's going to cancel with my x on the bottom. Okay, and so now I think I'm good to go ahead and plug in my 0. On the top, I just have a 1. On the bottom, I'll have a radical 1 plus 0 plus 1. So that's 1 plus 1, which is 1/2. All right, let's go on to L'Hopital's rule. So I have to warn you guys, this rule is kind of, in my mind, I think of it like the Pythagorean theorem of calculus, okay? And what I mean by that is when I teach my kids Pythagorean theorem, they start using Pythagorean theorem on every single triangle that they see. It doesn't matter if it's a right triangle or not. And so what I noticed with L'Hopital's rule is it's such an awesome rule. You guys are going to love it. And what will happen is it just starts getting applied to everything. So it's really important right now when we read about the rule to pay attention to kind of what has to happen in order to use it. So just like we have to have a right triangle to use Pythagorean theorem, we have some conditions to use L'Hopital's rule. All right, let's look at our theorem. Suppose that f of a equals g of a equals 0, that f and g are differentiable on an open interval I containing a, and that the derivative of g does not equal 0 when evaluated at a. Then the limit as x approaches a of f of x over g of x is equal to the limit as x approaches a of f prime of x over g prime of x. Okay, so what is it saying? It's saying if you have a limit where you're getting 0 over 0, you can do the derivative of the top, the derivative of the bottom. You do them separately. You don't have to do quotient rule. And then you just do the limit again. And if it doesn't equal 0 over 0, if you actually get a right answer, a real answer, then that is the answer. Okay, so let's look at some examples. So the really important thing is you have to get 0 over 0 to use L'Hopital's rule. All right, let's look at number 1. We just did this problem on the warm-up. Okay, so we already know the answer is going to be 2. So the reason we're doing it again is to show you how L'Hopital's rule works. Okay, if we plug in a 0, we get And this is what I want you guys to show. 3 times 0 is 0 minus sine of 0 is 0 over 0, 0 over 0. It's really important for you to show that because when that happens, that is when you are allowed to use L'Hopital's rule. Okay, so I'm going to write an equal sign and I'm going to put a little h over the equals. The h stands for L'Hopital's and it's telling the person who's seeing this, I'm doing L'Hopital's rule. That's how I'm getting the next step. All right, so we have limit x approaches 0. L'Hopital's rule says you are able to take the derivative of the top. So derivative of the top would be 3 minus cosine of x. You are able to do the derivative of the bottom. Derivative of x is 1. And now you do your limit again. Okay, so now let's try plugging in 0. We get 3 minus cosine of 0 is 1. So 2 over 1, which is just 2. All right, cool. It works. Let's go to number 2. We also just did this problem on the warm-up. And remember that we got the answer of 1/2. All right, so first thing we want to do, if we plug in a 0, that gives me 1 minus 1, so 0 over 0. When you get 0 over 0, you are allowed then to use L'Hopital's rule. We want to write an h on there to explain how we're getting something different in our next part. Okay, limit as x approaches 0. So we are going to do the derivative of the top. So we have chain rule, 1/2, 1 plus x to the negative half. Derivative of 1 plus x is 1, so there's nothing else I need there. And then minus 1, derivative of 1 is 0, so that goes away. Over the derivative of x, which is 1. Now I'm going to try plugging in my 0 again. So this gives me 1/2 times 1 to the negative 1/2. 1 to the negative 1/2 is still 1. So this gives me 1/2, which is what I wanted to get. Sweet. All right, let's try number 3. So first thing I want to do, plug in 0. Let's just see what happens when I plug in the 0. Oops. Okay, so this gives me 1 minus 1 minus 0 over 0, so 0 over 0. When you get 0 over 0, you are a candidate to use L'Hopital's. Okay, so I'm going to do limit as x approaches 0. Do the derivative of the top. So I have 1/2, 1 plus x to the negative 1/2. The 1 derivative of that is just 0. And then minus, this is x over 2. So remember, it's really like 1/2 x. So the derivative of that is 1/2. And then on the bottom, I have 2x. Okay, let's try plugging in 0 now. So I'm going to come down here. So when I plug in 0, I'm going to get okay, so that gives me 1/2 minus 1/2 over 0, so 0 over 0. Okay, so we actually just got 0, 0 again. So that means we're going to apply L'Hopital's rule again. Okay, so we're going to do a new L'Hopital's rule. So now we're doing the derivative again of the top and the bottom. So on the top, I will have negative 1/4, 1 plus x to the negative 3/2. The half, the minus 1/2 derivative of that is 0, goes away. On the bottom, I get 2. I'm running out of room. All right, now I'm going to try to plug in the 0 again. Okay, inside the parenthesis, that's just a 1. Anything, any power of 1 is just 1. So negative 1/4 over 2, which is negative 1/8. So the example 3 kind of shows you Sometimes you will get 0 over 0 multiple times. You can just keep doing derivatives of the top and bottom and keep plugging in your number. But remember, if you don't get 0 over 0 at any point, you are no longer able to use L'Hopital's. Okay? All right, let's try number 4. So when we plug in 0 originally, I'm going to get 0 minus 0 over 0, which is 0 over 0. Okay, so now I'm going to use L'Hopital's. So limit as x approaches 0. I'm going to take the derivative of the top. So 1 minus cosine x over derivative of x, which is 1. As a side note, another thing you're going to have to be careful of is once you start doing L'Hopital's and then I give you a derivative of a quotient and you have to use quotient rule, a lot of people are going to forget to use quotient rule. So just remember, L'Hopital's, you're doing derivative of the top, derivative of the bottom, but quotient rule you still have to follow when you're just doing normal derivatives. All right, let's plug in the 0. So 1 minus cosine of 0 is 1. This gives me 0 over 1, so my answer is 0. All right, let's read this little note here. It says, be careful to apply L'Hopital's rule correctly. It is tempting to apply L'Hopital's rule too many times. You must stop the first time the limit yields a quotient that does not equal 0 over 0. Side note, the L is not capitalized in L'Hopital's. Very interesting. It's a lowercase l. Okay, the reason why it was an uppercase L in the title is because you always capitalize the first letter of like a title or the first letter in a sentence. So when you're just writing the name, it's a lowercase l. Not that that really matters, but whatever. Okay, let's try number 5. We're going to start by plugging in 0, see what happens. So we have 1 minus the cosine of 0 over 0 plus 0 squared. That's 1 minus 1 over 0, 0 over 0. And we are good to use L'Hopital's. So we have a limit as x approaches 0. And so on the top, our limit or our derivative of 1 minus cosine x is going to be sine x. On the bottom, our derivative is going to be 1 plus 2x. Okay, let's try plugging in 0. So on the top, we have sine of 0, which is 0. On the bottom, we have 1 plus 0, so 0 over 1, which is 0. I want to just show you something. If you accidentally, let's say you were at this point, and you saw that the top was going to be 0, and you were like, oh, you got to do L'Hopital's. Okay, I just want to show you what would have happened. If you accidentally did L'Hopital's again, on the top, you would get negative cosine x. Sorry, positive. On the bottom, you would get 2. Cosine of 0 is 1 over 2. So you actually get a completely different answer when you apply L'Hopital's rule at the wrong time. Okay, so just be careful. Okay, let's look at number 6. On number 6, I'm showing you some one-sided limits. Okay, so let's try number 6a. So again, we first want to start by just plugging in 0. So we have sine of 0 over 0 squared. So that's 0 over 0. All right, so we're going to do L'Hopital's. So limit as x approaches 0 from the right. Derivative of sine, cosine x. On the bottom, 2x. Okay, at this point, when we plug in the 0, on the top, cosine of 0 is 1. On the bottom, I'm going to have 0 from the right. Okay, so what that means is I'm getting towards 0, but I am slightly positive, okay? So that means I get 0 positive on the bottom. And remember, when you divide by 0, that it means like I'm taking a cookie, right? And I'm dividing it into pieces that are minuscule, okay? The pieces are so small, you could basically think of them as nothing. And so how many of those nothing pieces would it take to create an entire whole cookie? that would be an infinite amount. Okay, so the way that the plus plays in is it's going to be positive infinity because of the plus, okay? All right, let's look at B. B is going to be the same thing, okay? We're going to do L'Hopital's. We're going to do our limit as x approaches 0 from the left, cosine x over 2x, derivative of that, okay? And so at that point, we're still going to get the 1 on the top. On the bottom, we're going to have 0 minus. So that gives us 1 over 0 minus. And the difference is that on this one, since our 0 is slightly negative, we're going to get negative infinity. All right, so you guys are trying your homework for 3.7, which is 3 problems using L'Hopital's rule. Good luck.